2 more 3s. I got 1 3. I need 3 3s. I need 2 more. And you can say it 3 squared or 9, take your choice. And so on the top, I have 3 times cube root of, that's 9. And here's where it simplifies. Cube root of 3 cubed is going to be, what? 3. Yeah. If the exponent and the index are the same, they in essence cancel each other out. So the cube root of that 3 cubed is 27, the cube root of 27 is 3, or the cube root of 3 cubed is 3. Take your choice. So I get 3 times the cube root of 9 over 3. I have rationalized the denominator. Am I through? What else can you do? That's right. Do what you've done with fractions since a long time ago. If I have a common factor top and bottom, they're out of here. So my final answer, cube root of 9. Hey, that's pretty good, huh? Notice how the whole strategy changed when the index changed. The index tells me how many times I want something to show up in order for it to simplify. I need something to show up 3 times before a cube root simplifies.
I have a question.
Yes, ma'am.
The 2.
Did you say 2?
Yeah, the 2. Like
Did I put 2 in there?
the power.
Oh, the 3 squared?
Yeah.
This guy?
Yeah.
Where did it come from?
Mm-hmm.
Okay. First property of exponents. Look here. I got 3 to the 1. I want to end up with 3 to the 3. What do I multiply 3 to the 1 by to get 3 to the 3 to the 2?
Oh, yeah.
Add your
Okay, I get it.
Okay. Good question. If anybody put cube root of 9 in there instead of that, that's great too. And you ended up with a cube root of 27, that's great too. That's a perfect cube. Question on that, kid? Yes, ma'am.
I'm sorry, I'm a little off on the last part. What
Okay.
happened to the
Let's see.
at the bottom, where you can't stop the,
This guy
yeah,
to here?
right.
Okay. If I have a exponent and a index that are the same,
They cancel out.
it's just the base.
Okay,
So here's another way to think of it. Go to your 3 by 5 card. Radical expression. This is the same as 3 to the 3 over 3. This is 3 to the 3 over 3. That's 3 to the 1. That's just 3. But a good way to think of it is if, and possibly, I think possibly I shouldn't use that many 3s. I should have used something else for my base. Kind of got overwhelmed there with 3s. But if I have something like the 5th root of a to the 5th, what's that going to be? It's just going to be a. In essence, the exponent and the index cancel each other out. Why? Because that's a to the 5 over 5. That's a to the first. That's just a. So we just skip that middle step and go right to the fact that if the exponent and the index are identical, they cancel each other out. All right, that was challenging. Let's look at one that's even as challenging. That looks a lot less. Notice the difference between this problem and the last ones we were looking at. The last ones we were looking at just had a single radical in the denominator. This got a 2-part denominator. One part of which is a radical. I'm sorry?
You still have to multiply the whole thing.
Still gonna multiply top and bottom by the same thing. And notice if, by the way, let's just say, hey, square root of 2, it's worked before. I think I multiplied top and bottom by square root of 2. 1 times square root of 2, that's good. Hey, I got 2 things to multiply by 1 thing. What property do I use there? Distributive, So I gotta multiply this times that plus this times that. 3 times the square root of 2, that's 3 square root of 2's plus
2.
square root of 2 times square root of 2 is 2. And got rid of the radical there, but picked up a radical there. Didn't work. Okay? So multiplying by the simple radical does not get me where I want to go. Still have a radical in the denominator. So let's start over. I am, go ahead and tell you, I am going to multiply top and bottom by the same thing. Anybody know what the same thing is going to be?
All of it 3 plus the square root of 2.
Multiply by 3 plus the square root of 2. How many would go for multiply 3 plus the square root of 2? Let's see what happens. By the way, if I multiply 2 things by 2 things, what do you call it? FOIL. You've done that before? If you multiply 2 things by 2 things, you've got to do the FOIL, first, outer, inner, last stuff. Here we go. By the way, if you're writing in ink, don't write this down. 1 times something is just the something. Here we go. 3 times 3, that's 9. 3 times square root of 2, that's 3 square root of 2's. 3 square root of 2 is 3 square root of 2's again. Square root of 2 times square root of 2 is plus 2. Okay, 3 plus square root of 2 over, that's 11, plus 6 square root of, still got a stinking radical under my denominator. Yes, ma'am.
Multiply by 3 minus square root of 2.
3 minus. Let's try that. This one didn't get us very good. That was a good thought, though, a very good thought. Let's multiply top and bottom by 3 minus square root of 2. Okay, again, 1 times anything is just anything. Once again, 2 things times 2 things, gotta FOIL it. That's a 9. That's minus 3 square root of 2's. That's plus 3 square root of 2's. And that's minus 2. See that? Minus 2. Square root of 2 times negative square root of 2. Plus times a negative is negative 2. Look, ladies and gentlemen. Oh my goodness. The radicals, they're gone. And I get 9 minus 2. I get 7. A harmless, rational 7 as my denominator. We finally got there. We considered just multiplying by the plain old radical, didn't work. Considered multiplying by the 2-part expression itself, came close, but didn't work. Then we multiplied by this 2-part expression, changing the sign in the middle, and ladies and gentlemen, this and this, when considered together, they have a name. You know what they're called? This is the something of that. Not the reciprocal, not the inverse.
The opposite?
Not the opposite. Opposites add to 0. Those don't add to 0. Conjugate. Very good. Heard of conjugate before? Yeah. Probably heard the term conjugal visit in a jail. The idea things get along really well together. So these guys get along really well together, all right? They're conjugates. Hey, there's a multiple choice question for you. Notice how you get a conjugate? You change the sign in the middle. That's it. Just change the sign in the middle between 2 things, and you have the conjugate. But look at the beauty of the conjugate, ladies and gentlemen. You multiply conjugates, you eliminate the radical. You get a rational number. Did you notice that? Let's try one. By the way, What's the conjugate of 4 minus the square root of 3?
4 plus the square root of 3.
4 plus the square root of 3. Absolutely. Let's multiply those together and see what we get. You got to foil it. That's 16. That's plus 4 square root of 3. Minus 4 square root of 3. Plus times a minus is going to be minus 3. Equals 13. Good old radical-free rational number, 13. Hey, look at the example of when we multiplied conjugates.
Thank you.
We multiplied conjugates with the FOIL, the O and the I. The O and the I will always cancel. Always, always, always. Multiply conjugates, the O and the I will always cancel. So you can just kind of take a shortcut. Instead of doing the FOIL, instead of doing the FOIL, you can just do the FLO. Just the F and the L. All right? Just the first and the last. The O and the I are going to cancel anyway. So if you want to save yourself a little time, a little ink, just the first two and the last two. There's always going to be something minus something because of the nature of the conjugate, a positive and a negative among the last terms. Hey, can you have that? You're given a two-part denominator, one of which is a radical. I got it. You just multiply by the conjugate. Change the sign in the middle. You're going to see the radical parts cancel out. All righty, that's number 3. And the last one. And this is also easy. No fraction may appear within a radical. Well, a simple question presents itself. Well, what if it does? What if you have the quantity 2/7 and you want to know what the square root of that is? You can write that as the square root of 2/7. But what this says is that's not quite kosher. It's not quite an acceptable way to express the square root of this value. So here's a shortcut. Watch this. This is one of the properties of radicals. It says this. You got a fraction, you have a radical of a fraction, that's equal to a fraction of radicals. You got a fraction underneath the radical? That's equal to a fraction of radicals. Just one radical over the other. Just the in this case, square root of the numerator over the square root of the denominator. Okay? So we no longer have a fraction under the radical. Thank you very much. Uh-oh. But we created another problem, right? We now have a radical in the denominator. But we're not confused. We're not flummoxed. We know exactly what to do. What do I multiply top and bottom by here?
7.
Square root of 7. I do. So you resolve number 4 by creating a number 3 problem, and you can resolve that easily by multiplying top and bottom by that denominator. Can I multiply square root of 2 times square root of 7?
No. No.
What do I get when I multiply square root of 2 times square root of 7?
Don't they just sit next to each other?
Well, that kind of...
And the bottom is the bottom of the one.
What do you mean?
Like they'll equal to
You mean square root of 2 times square root of 7?
yeah,
Yeah.
and the bottom would just be 7, the square root of 7, or maybe 7.
The bottom's going to be 7. I'll grant you that one. Hey, what's square root of 2 times square root of 7?
7, 14.
Square root of 14.
Also we do.
You can multiply. You can multiply radical expressions if your indexes are the same. I can multiply square roots times square roots, cube roots times cube roots. No problem. Ta-da! Here we are. All right, watch this, ladies and gentlemen. Watch this. Square root of 14 over 7. Aha! Both these guys have a factor of 7. What did I do? I tried to simplify inside and outside of a radical. You see, ladies and gentlemen, that's not a 14 there. It looks like 14, but it's not really 14. What is that in the numerator? That's the square root of 14. It's somewhere between 3 and 4. It's a square root of 14. It doesn't have 7 will not divide into it even. Okay? So I cannot simplify a radical and a non-radical number. Square root of 14 over 7 is just square root of 14 over 7. Okay? But watch this. You think I can simplify that?
Yes.
Look at what our first step suggested. That if I have a fraction of radicals, I can express it as a radical of a fraction. So I can re-express this as that. I can simplify, or I can just skip that middle step. I could say, okay, that's 2, that's 1, that's square root of 2 over square root of 1, but square root of 1 is just 1. Either way, you're going to get the square root of 2. So bottom line, I can simplify fractional expressions if they're both radicals. And of course, you know, I can simplify fractional expressions if they're both non-radicals. Okay? So give me 2 non-radical numbers, I can simplify. Give me 2 radical expressions, I can simplify. Give me 1 of each, leave it alone. Okay? 1 of each, don't try to simplify. All right, ladies and gentlemen. That's the 4th standard for simplifying a radical expression. Anybody got a question on any of these 4? So when you are presented with an expression that has a radical in it, and your instructions are simplify, you might want to be aware of these 4 reasons that a radical expression is not simplified, and see if any of them apply. Okay, so far? All right. Let's open up the WebAssign.
I'm not going to be giving
How many of you have actually opened up WebAssign, at least looked at an assignment?
Yeah.
Okay, that's good. I mean, that's good.
Because I guess I'm dead. Guess I'm dead to pay for it. I can't afford $60 right now. I mean, I would be able to if I hadn't had to do something with my first refund, but the second one's coming on the 15th, so I should be okay. But until then, I'm so happy I have no math. I have no math. I can do it.
When's our first meeting?
25th.
25th. I should have because I have it shipped off tomorrow. Mine shipped off.
All right, here's what I'm going to do. I'm going to go to the open student view, which means I'm going to see, hear what you see, not what I, in my privileged position, get you see. Your section 8. We're looking at P2, exponents and radicals. Click on it. And here's what will show up if you haven't opened it up before. So far I have a 0 on this assignment. This will show you which ones you've done successfully, you've done none of them successfully, our score at present is 0. And there's the first problem. Now, what you can't see, that I can see, is that a lot of this stuff shows up in red, which means that's the thing that's going to change from like student to student. So while your problem may have different numbers in it, it'll be the same concept. It'll look just like the same format. So here's what we got. Can I focus?
Can we turn the light on, like right in front of it?
Yeah, can somebody get the, I think the light switch closest to the back? Is that better? Okay. All right. Okay. Here's what you got, ladies and gentlemen. You've got an example in this first problem of both properties of exponents. 2, 3, 6. All right. What do you do first? What's inside, right? That's a good rule to keep. You know, please accuse by hearing stuff. Parentheses. Can you do something inside the parentheses? Yes. Go ahead and do it. What is 2 to the third times 2 squared? 2 to the what? That's kind of important. To the fifth. That's the first property of exponents. If I have the same base, I add my exponents. So I get 2 to the fifth squared. That's the second property of exponents. What do I do with those two exponents? Multiply them. If I have a power to a power, 2 to the 10th. Let's see what the instructions are. Evaluate each expression. As soon as I hit this, I will notice that no little screen comes out as far as giving me the opportunity to do radical expressions or exponential expressions. So I just got to put a number in, ladies and gentlemen. Anybody want to figure on your scientific calculator 2 to the 5th power?
1,024.
1,024. And once again, that's something you can do very easily on your calculator. So 1024. Everybody okay with that? If what? If you do watch it, I don't know. You want to try that? Oh, yeah, is that okay? It did multiply the 2 times these guys first? Yeah. That's fine. So you get 2 to the 6 times 2 to the 4. And add those, you get 2 to the 10. Okay. Either way. All right. This guy, -3/4 cubed. Great, I just started to feel good and then put some fractions in. 4/3 squared. Let me just make an observation here that might help you avoid an incorrect answer. What's the sign of my final answer going to be? Positive or negative?
Negative.
Let me go for negative. Absolutely correct. All right, the positive fraction has nothing to contribute about the sign. It's this guy. And I have a negative number to an odd power. So this is going to be a negative number. Negative times a pi, negative. So I'm going to get a negative outcome. All right. Here's a way to do it. There's a bunch of ways to do it. Do the watch it and you'll get a way to do it if you want to. But here's the way I'm thinking. I got stuff to a power here. Powers to a power. So I got 3 to the 3rd on the top. It's going to be negative, right? 3 to the 3rd on the top. 1 times 3. 4 to the 3rd on the bottom. Times 1 times 2. 4 squared on top. 3 squared on the bottom. So I got those two fractions to multiply together. Now you could go ahead and find out what 3 cubed is and 4 cubed and multiply on those numbers.